Hey, what up, guys? Daniel Dallas is on the line. I was asked by students to clarify this topic, direct and inverse proportionality. So what it means? Actually, it's pretty easy. If you consider direct proportion, so direct actually means that you have the straight line that goes with a specific gradient, all right? So in terms of y from x, it should be the following. So direct means that y is some coefficient, let's say, I don't know, so it's better say a times x, all right? So because this is an equation of a straight line, no matter which coefficient you will use, a or like for a standard line mx, it doesn't matter again. And you see that the more x, the more y, okay? So however, there might be negative gradients, like for example in this case. And so one more time, let's do it more clearly. So it goes through origin. All right, so in this case, gradient is more than 0. In this case, so gradient is less than 0. However, still direct proportionality. All right, so general equation for direct proportion is just y equals a times x. So a is just coefficient. Keep in mind, it's not a variable, so this is coefficient. All right, so what typical task might be? In order to, they are designed to define coefficient a. So for example, let's say that we have y directly proportional to x. So the keyword here is directly proportional. All right, so y is directly proportional to x. And for example, you might be given conditions. Let's say when x equals 10, so y equals, let's say 40. All right, so you need to find or determine coefficient a and exactly write the formula. All right, that's typical task. Okay, so one more time, we use the keyword directly proportional. So we just write in this formula. And now in order to define coefficients, we just plug the values. So we know that when x is 10, so when x is 10, y is 40. Of course, we need to plug those values instead of y, 40, and instead of x, we just plug 10. Okay, that's how it works. From here, you set up an equation for a. No more variables, no more y, no more x, because you already plugged them in. All right, so from here, a is just 40 over 10, or you can cancel. That means you have 4. All right, so you define value a, so a equals 4, and now we just need to plug it back here in order to get the right equation for your case. So y equals 4x. So if you're asked to draw, just use straight line. All right, that's your line with coefficient 4, so with gradient 4. All right, so okay, maybe you just, if you want, you can set up even a table to have 2 points. So the first point is just the origin, okay, 0, 0, and the next point, let's say, just plug any value instead of 1x, let's say it's 1, and means 4 for y. Okay, so gradient is 4, so that's it. All right, here how you can visualize this direct proportionality. You might be given different tasks, but they're almost the same. For example, there might be the case that, let's say, we know that volume, for example, let's take a cylinder, and we know that the volume is directly proportional to height, right? It also directly proportional to the radius of the top part. So because we know the formula is just height times the area of the base, that's really universal formula, and we can say that h times pi r squared. So as we can see it for a fixed value of h, let's say h is fixed, and we want to explore how your volume dependent on r, so you can put quadratic dependency, right? So pi h r squared. So that's actually quadratic dependency. But if you said that volume is directly proportional to r squared, so you see, not to r but directly proportional to r squared, you'll get the following, that from r squared is actually all that becomes a new coefficient, let's say k. So it's k times r squared, all right? So now we have the same direct proportionality because now we exploring dependency from r squared. So for example, you might be given again that when radius is 10, let's say volume, say centimeters, so volume is, let's say 40 centimeters cube. All right, so what it means that we again can plug the values and figure out that 40 volume equals k times, be careful here, radius squared, right? Don't forget that it's square. So that's why it's going to be 100. So in this case, k is equals to 40 over 100. Oh, just cancel 4 tenths, so 0.4. All right, so we can say that it's going to be 0.4 times r squared. That's the general formula. All right, direct proportionality, volume versus r squared. All right, I think that's enough, and now we just go back and see what does mean inverse proportionality. Inverse, if there were before there were straight lines because volume or any other value was proportional directly to the value, to another value. So in this case, y should be inversely proportional to x. So inversely proportional means greater x, lower the fraction, and lower the y, okay? So in this case, we need to use this formula. So for inverse proportion. Okay, how to use in the same manner. So you know probably that if you start plugging the value, so you just basically create a table x from y. Let's say we have specific graph 1 over x, and let's see how it works. I know that GCSE students never seen it before, but so it's not hard to depict and so to understand what inverse proportion is. So just start plugging value. You cannot put 0, right? Because you are not eligible to divide by 0. So you plug 1, let's say 2, let's say 4, let's say 10. Okay, let's calculate the value. So y is 1, then 0.5, then 1 over 4. So that's basically times, so 0.25, right? 1/4. And 1 over 10 is 1/0. So what it means that if you have values 1, 2, let's say 4 and 10, your y is going down, all right? It's falling. So your function should behave like that. So we have different points, but anyway, it's decreasing curve. So when 1, there is 1, and now it starts decreasing like by half, by quarter, and here it's like 0.1. Okay, you see that's inverse proportionality when k is more than 0. So in this case it's 1. So we understand that it's falling dependency. All right, the greater x, because we moving in along x direction, that is rising. So x is rising while y is falling. So that's why it's called inverse proportionality. All right, how to work out coefficient value? So you need to work out in the same manner. Let's say we have the function y equals k over x, and now we just need to figure out k when, let's say, y10, when y10, so your x, let's say 1. All right, what you need to do is just to plug the values. So this principle works the same in direct and in inverse proportion. All right, so x equals 1, just k over 1, or k equals 10. All right, so that's how can be worked out. So in this case, we'll get 10 over x. All right, so that's it. So probably I can give you an example from physics. Let's say we have two charges. So positive, let's say proton and negative electron. So if you connect with a straight line, you'll have the distance r. So r is the distance. And you know, according to Coulomb's law, there is specific force of attraction, right? You know probably that from GCSE topics in physics. So you know that this force, Coulomb force of attraction between positive and negative charges, is actually proportional. So proportional to the product of P times E, that means product of their charges for two particles, and we take in absolute values, and inversely proportional to square of the distance, and k is coefficient of proportion of this proportion. All right, so you heard the word, it's exactly in definition, right, of a Coulomb force relating to the distance between two charges and charges itself. So you heard the word. So F directly proportional to the product, okay, and inversely to the r squared, to the distance between them. All right, so that's how it works, and I hope you understand, and moreover you can apply this concept, for example, in physics. Thank you guys. So I was very amazed that I've got comments to explain specific topics. So actually, you know, the channel is designed exactly for you guys, for those who want to learn the concept. So learn by heart or just understand. I try to put clear explanation for each topic. So waiting for your comments, and